I've known Bill for a couple of years now as well, since he started doing some things with Omnex on the aerospace side. And Bill has a lot of background with Department of Defense, with supply chain, logistics, that kind of thing. So he knows a lot about the APQP and some of those flow downs from there. So I'm going to turn it over to them and let them present. So Bill, if you want to share your screen, whoever has the presentation, I should say, whoever wants to share it.
All right, so I'm Bill Ireland. I've had probably almost 30 years with automotive. Pretty interesting career started me out. I was senior reliability for the cruise missile engine development back in the 78 time frame. And it's always been a helpful resource in perfecting APQP so that the outcomes are better production outcomes, more robust. All right, so try to figure out how to advance the slides. There we go. All right, so basically the AS9145 in some context, uh, um, it became clear to the aerospace community that the automotive industry had a pretty good lock on improving quality in complex systems, and yes, they had a lot more quantities typically, but they wanted to leverage what was a big success for the automobile industry, coming up with a standard way to develop a program and then validate that the production line is ready. And so that became the AS9145 standard. At the same time, and a little before the standard was released, I was working with the DoD, and I did a master's program in systems engineering at the Naval Postgraduate School. And my topic was alternate production approval process for the DoD, and did a lot of study into aerospace, medical devices, and the DoD and the automotive industry, and compared and contrasted the integrity of establishing a design for production, and that the APQP process was itself the best practice. And the GAO that made reports to Congress on approximately 100 major weapon systems indicated the same need, that there needed to be a standardized approach to validating production. But it's hard for everyone to say how to do it. There is a group in the AS standards community that are the jet engine community with the AS 13,000 series, and they're not shy about being prescriptive if a best practice works. And I think that I will be presenting some nuanced findings about the compelling reason why the AS 9100 is a nice structure, but you really do need to dive in and use these tools that have created such a robust quality standard for those that are in production. In the process of updating APQP and PPAP, the AS9145, I'm on that committee as well as a liaison member. And when I was there in March of 22, North Carolina, where they had their meeting, the first in person after COVID, uh, and having a DoD background, and the standard was, aerospace, space, and defense. And I questioned if there was really any defense meeting of the minds in this standard, because it was mostly commercial aerospace that were present. And and I suggested a few things, and so they halted the publication and the balloting for the standard at that time, and myself with some DCMA, Defense Contract Management Association, responsible for, I believe it's like 300,000 contracts, and they want to see better outcomes as well. and the GAO suggested similar things. And so there is a contingent trying to make sure that this standard is as broad as it says in its title. And so we've submitted, a couple of us in the committee have submitted suggestions for change, and that there be a stronger reference to the how-to, and that there in the 9100 change that might be an F. We're also trying to make some changes there where we uplift the activities that are called prevention activities, because APQP, Advanced Product Quality Planning, is putting the investment in so that you have a robust production process, a design that can meet requirements at the quality that is demanded for systems today, and as complex as they are. So we're looking forward to some of those changes taking place inside these documents, and that's through the SAE G23 committee. The G22 is supply chain, and the G14, I hope I don't have them mixed up, but the G14 is the manufacturing one, where I've reversed the 23 and the 14. So the manufacturing one, it has the AS standard, AS 6500, which is a manufacturing plan that has a contract data requirements list and a data item description that tells form and content that should be in a manufacturing plan. And in part, they do reference in name APQP in a dovetail sense, and some of the best practices. And there is an Air Force version of best practices that capture the APQP activities in a document called Milled Handbook 896, which I'm also a member of contributing to making sure those documents kind of dovetail with APQP. So there's some weaknesses in the cross sharing of this information and these best practices. And so I am looking for a little more changes than Craig was mentioning, leaning towards the prescriptive sense. And then I'm involved with DCMA in Congress and trying to affect the defense authorization for 24 and 25 in particular, that will upgrade uh, the win-win situation that APQP will bring to the defense industry, which heretofore kind of ignores it. Although it's interesting that the ITAF 16949, I think that's the number, that it's mentioned in the DFARS and the FARS, the Code of Federal Regulations, as a legitimate recommendation for complex systems that need a quality management system for their programs. But it's AS 9100 is usually chosen and without any customer specific requirements and without any data that would validate in the V model sense, in the systems engineering sense, would validate a production line's readiness for production. And that's just left for a question set. So if we look at that cycle, came up with the standard, leveraging what the automobile industry did, the work in progress, and then dropping the ball for a couple years, and now they're picking it back up again. And I look forward to the strengthening that with that community of people. The next meeting that they'll have, I believe, is in Melbourne, Florida. And Craig, the meeting that you attended, was that San Francisco? Yeah. All right. And before that, there was a September meeting trying to bring this into development so they can finish it. The 2016 version is still the released, the original version. One of the things about the requirements is the relationship to some other standards that were mentioned. And the remote standard, there is a remote standard, Craig, and I don't know if I wrote down the number, but it's not an AS standard. It's an I think AIA standard, NS something. And I think I'll bring it in a little later in the presentation. but how to do things in the remote sense. But the 9102, everyone is familiar with, and that's the Craig mentioned that, and that's a supporting standard for first article inspection, which is a kind of a onesie look at, can you fabricate something from a DoD point of view, and to say, can I make it to requirements? But the 9103 is spotty in terms of its application. And really the essence of APQP, a good APQP program, if you follow it, is supposed to feed a control plan. And the control plan that says, I've defined where the risks are with regards to functions of design that may have adverse variation would mean that the function would not be achieved. And what we're trying to do is minimize that adverse relationship. And what I tell people is manufacturing cannot make your design any better. We can only make it worse. But we're trying to make it as least worse as we can. And that's what APQP will do for you. It will understand that variation, put your arms around it, and how do you select what you should control is a process that one can look at. And I suggest an idea in this presentation in a few slides. Standard Works is the SAE's framework that tracks and as a work product these things. And this slide is just showing that the 9145 in its present status, taking this chart from a couple days ago, is just in the issued status. They don't show it as a work in progress yet, even though it was mentioned at the San Francisco meeting. So I find that it's probably true that it's moving into this work development status, and I think it needs to have some changes. The changes that were proposed in 22 are in red here. So if they adopted what had been written in 22, it shows by element the 11 elements that are tracked in the phases that they should go in. They were looking at production control plan. If I focus on that, because that's the AS 9103 in part to me as having a good control plan, is they moved it from an earlier phase to a later phase. And I suppose from my point of view is it's developmental, and you should have a draft in the third phase, and then the fourth maybe you would call that final. But that's waiting pretty long to communicate to your teams what's at risk, and you should be finding out what that risk is sooner. An explanation of the phases, they really aren't any different than they were in 2016. It's primarily carryover. We're familiar with the context of the V model that was here. Some people say they softened the idea that you develop and validate and verify the V model, but I think it's here to stay. And one of the overlaps between APQP as stated here and the Department of Defense is that there is a production readiness review, and there is a phased development. And I thought it would be important, and one of the suggestions that I've put to the committee is to look at this slide here, which is the typical acquisition life cycle of the Defense Department, where they have milestones A, B, and C, where B is representing development and C is the production. And you have your preliminary design review that says I've designed it right as best I know from technologies that are available for the capabilities of interest in the requirements generation, to the critical design review where you're going to have like 90% of your drawings released and say I've designed it in a way that I can manufacture, and then a decision to go into production. And so there is an alignment that exists, but I'll point out something different than that I don't see in aviation or medical devices or automotive is a formalization of low rate initial production. And in part, I don't think it should exist because what it means is I'm going into production, but I don't know how to make two in a row. And And the reason why defense doesn't know they can make two in a row is they're not required to know. And so no one makes a point of demonstration, which is, I think, the object where we need to move is demonstrate, even at the lower quantities that might be in defense, the benefits of APQP and a demonstration of production readiness, and not just a checklist of risk of production readiness. So that you could go right into full rate production. And so I've lined those two things up for the committee, and this may appear in the next generation of APQP in 24 or 25, and I hope it does, because I think it's the only industry that I've assessed, which includes the food and drug, the aviation, for the medical devices, and the um, automotive and the DoD. And the DoD is the only one that doesn't have a production approval process. Uh, one of the things I find in this idea of not telling you how to do something when you know that a how is actually effective, I don't think there's anything wrong or bashful about making a standard out of something you know that works. And but I know there's resistance. I know that the committee in 22 in developing the standards were resistant to bring the engine quality AS 13,000 groups uh, approach to prescription. They didn't want that to appear in the regular AS standards. So they put them in the backup standards here, guidance ones. I might suggest that, how do you get to a good control plan is AS 9103. It's going to be listed in AS 9100, a little more clarity as a note. It was just told us by Craig. And, uh, and then if you wanted to look at model-based systems engineering, it's, and use those tools for the manufacturing requirements definition, I think you'd be miles ahead. And so I'm just offering this out there, that how do you take design risk, which you must evaluate, and how do you take process risk, which you must evaluate, and associate where the process that touches technical performance measures of importance, and how you come up with your control plan or your key characteristics that are subject to control plan. And so this is a pretty good technique. It has more parts to kind of get to this, but I just thought I'd push that out there because to me, when I did programs for the Defense Department and weapon systems, I asked myself, I go, you can't ask for the universe from people, but what can you ask for that's key that gets you to the goal? And that's a control plan. So I put AS 9103 out there. And if you did that well, it meant you did most of the other parts of APQP well. The handbook I mentioned, 896, Mill Handbook 896, it's in review now, going from Rev A to B, and I comment on them that they should be more AS 90 9145 friendly, and realize that that they're partners instead of stovepipes to having proper outcomes. Recommendations for DoD, if you're thinking about that universe, or I find that when I'm going around companies here in Michigan in particular, that those that have been traditionally automotive supply companies, they want to diversify. They want to get into the space LOE market. They want to get into the ground vehicle defense market. And so we're strong here with regards to APQP coming from the automotive industry, and I think it's a place where the let's say Pathfinder projects can take place, and come up with a value proposition. And in contracting, what I'm working on with Congress is to come up with like an incentive contracting plan where you would get, if you could get, let's say, I'll give you $10 million if, let's say the scale of the program is appropriate for this. You start having your supply chain follow AS 9145. And if 80% tried to follow it and 80% did a PPAP, and you multiplied those two together, you'd give 64% of that $10 million to the contractor. And if I think over 3 years, you could affect the value and the savings that you would gain by everyone standardizing how you come to production readiness instead of everybody doing it differently. And what I'll be working on with DCMA is to come up with seed drills like AS 6500 has, but for APQP. There are a few things I want to point out to kind of close things is that we often miss the compelling reason why this should be done and the amount of benefit to these things in terms of the bean counters or the money involved or the savings that's possible when you apply these standardizations that work. And there was a survey done 10 years after ISO was released, and another survey done by one of the people that works here with Omnex, Dan Reed. He was one of the facilitators of the survey with ASQ, and the other was with McGraw-Hill, that looked at about 1,000 companies each on following ISO, 9,000 versus essentially an IATF 16949 or a QS 9000, which is essentially AS 9145. And I wanted to show these results that were there. And the GAO adopted this, and I've influenced them, I think, because I sent them my thesis and they changed their scorecard, how they looked at weapon systems in the same way. They call it a knowledge point 3 that looks at manufacturing, and I'll get to the survey in a second. Is that the demonstrator readiness, they call it a readiness of at least 9, but that just means that you've done APQP and PPAP. That's what that means. It's the same thing. And so they adopted this instead of just saying, let's do SPC. And then you see these dots on the right that the circles are not filled in. That means they're not doing this work in the industry. Just kind of looking at the scorecard that was in 2013 in contrast to the GAO scorecard on weapon systems in 2017, where they've made this switch to look at this level 9, and critical processes are in statistical control. And I have a graphic. I won't spend any time on this. It's more for the DoD people. But the things in red on this chart are if you move essentially validation of the production line to the left, and you don't go through this LRIP, and you apply APQP in appropriate ways, like AS 9145. So if you adopted AS 9145, you wouldn't just use a checklist to see how you're doing, but you would actually demonstrate in a PPAP data fashion. So there's 11 data areas, and the first article inspection is one of them, qualification is one of them. Those aren't new out of those 11, but getting a production line demonstration they don't do that. Like I said, the DoD is the only group that doesn't look at things that way. I looked at a series of industries and their relative size as part of my research, and saying these 4 groups: commercial aerospace, automotive, medical devices, DoD, they're all in scale on the amount of activity in manufacturing. And then this is the survey results that looked at both the cost of registering a third party, and some time ago was in 97 and in 99 by McGraw-Hill, and looking at these companies. And it basically was saying that the 3-to-1 return on total costs, they were looking for ROI, and an improvement of 6% on sales when you did this more prescriptive QS 9000 or APQP approach versus the ISO 9000 approach, where 1.3 to 1 return on total cost. So there wasn't as much improvement there. At 6% of respondents on ISO indicated a reduction in defect rate due to following that standard, where in contrast, you had a 50% of respondents said they had at least a 50% reduction in defect rate in the automotive universe. And so for those that are statistically inclined, I have a chart here that shows that there is a significant difference. And I want to thank you for your time.